we'll go for applications. So these are 4 applications. First we will see the first application, that is knapsack problem. So we'll see what is this knapsack problem. The problem statement is, here we are given n number of objects and a knapsack. Knapsack in the sense it's a bag with a capacity m. So here it's just, let us consider like a person or some distributor who takes bag. In that bag he has to take the product and he has to sell the products, so that he has to get the maximum profit. So like that only. Here also we have n number of objects. Each object has weight, that is Wi, and profit also. The problem is to fill the bag with the help of n number of objects, and the resulting profit has to be maximum. So he has n number of objects with him. He has to place the objects inside the bag so that he has to get the maximum profit. Now we'll see this one with an example first. Let us consider there are 3 number of objects, P1, P2, P3, those are profits of objects. So initially we have 3 objects, and profit of the first object, that is 25, weight of the first object, that is 18. Like this P2, W2 are there, P3, W3. And here M is given, M is 20, that means the capacity of the bag. That means the knapsack has weight maximum of 20. Let us suppose it is 20 kgs like this. So if it is 18 and 15 and 10 kgs, like this, the capacity of the bag is maximum, that is 20 kgs. So now we need to place the objects in the bag such that the profit when he takes the objects in the bag, when he sells it should be maximum. So we will see that one here. Now how can you take it? Here you can observe one thing, that is, if I take the first object, here we have a flexibility that no need to take the entire object, you can make it half and you can take, or else you can make some fractional part, not only half, fractional part of the object also you can take. For example, if I take 18, the total weight of the first object is 18, you can take half of the object also. That means the weight will be 9, and at the same time profit also will be half, that is 12.5. Like this you can calculate here. So this is what happens here. So we'll take some examples. Now x1, x2, x3, this means x1 in the sense with how much fractional part of the first object you have taken. x2 is like this for second object, x3 is for third object. Now we can have some possibilities how we'll take. Let us suppose I'll take entire first object. If I take, what happens, we'll see the profit of the total system, total bag. So that can be given here. Of course this is the problem statement is given here. I'm writing here maximize the profit in the sense Pi into Xi, where I is from 1 to n number of objects, such that the weight should be less than or equals to capacity, that is Wi into Xi is less than or equals to the capacity, where I is from 1 to n, and of course I have written I is from 1 to n, and what about x, the value of Xi must be from 0 to 1. Of course it's a fractional part you can take. If Xi is 0 means you are not taking that object, if Xi is 1 means you are taking the entire object. So that is a mean. So like this, my first option, I'll go for like, I'll take the entire first object. If I take, that means what is the weight of the bag, we'll see. That means if I take the first object, that means W1 18, I'm taking 1. What about this profit of the bag right now? Profit of the object is 25 into 1. Now what about the capacity of the bag right now? 20, and now the weight, total weight in the bag is 18, so remaining is only 2. The weight you can put is only 2. Now if I take the second object, the total weight is 15. Among 15 I can take only 2 by 15th part out of 15. I cannot put the entire bag, so that's why. So the total weight of the bag now is 20. In that case, what will be the profit? Profit of the second object is 24. In that I am taking only the fractional part is 2 by 15. So like this you need to consider. Anyway, 2 by 15th part. Now the bag is full, that's why no need to take the third object. So like this you need to consider. So this will become 28.2. So I will go for another option. I don't want to take entire object, I want to take like half of the object. Okay, like if I go with the half of the first object, 9 into 1 plus, that is of course you can take it as 18 into 1 by 2, and profit is pi into xi. Profit is 25 into 1 by 2. Now the weight of the bag is 9, the remaining is 20 minus 9, 11 is there. Now I will go for 15. You cannot take entire second object. Let us suppose if I want to take the 11 of the 15 object, you can take like this, or else you can take 10 of the second object. If I take 10 part, that means 15 into how much I want to take, 10 only, that means 10 out of 15. Now 10 out of 15 here. So here profit will become 24 into 10 out of 15, you can see. Now this weight is 9 plus 10, 19, only 1 is left. 1 out of 10 I can take on the third object. 10 into 1 by 10 you can take. So this will become 20. See, this total weight should not exceed 20. It may be less than or equals to 20. So here the profit is 15 into 1 by 10. So like this you can take. So the value is 30. So like this you can have any number of options you can take, or else you can go for entire second object, then third object, then first object, or else entire third object first. Like this you can take. And you can observe here, whatever the profit you are getting, all these things are, we call it as feasible solutions. So every solution is acceptable, but what here is asking is you need to maximize the solution. So how to find this maximum value? So among these number of options, how can you find the optimal value? What procedure you need to follow? So to find optimal solution, we have a procedure that first to find the profit by weight ratio of each object. So like this P by W ratio you need to find. So here I'll check it. So profit by weight ratio, that is first object 25 by 18, second one 24 by 15, third one 15 by 10. If I take like this, the value will be, this is approximately first one 1.4, this is 1.6, this will become 1.5. Like this you can take the first one. Now after finding profit by weight ratio, you need to take the objects in the order of, that is descending order of their profit by weight ratio. So highest value profit by weight ratio, you will take that object first. So among these three, the highest is this 1.6. So I'll take the object 2 first, then object 3 next, then the object, this one is third. Like this I'll take. So if I take in this manner, that means whatever the second object I need to take first. So like this if I take, so this is a profit and I'll write here WI into XI. So first second object, that is 15 into 1, I'll take entire object. Now, so if I take the object second, that's why I'm taking second object is, which is having the highest is 1.6. So that's why the weight is 15 into 1, and respective profit, that is 24 into 1. Like this I can take. Now what about the capacity of the bag? 20. Now it is 15 over. Now only 5 are left. Now I need to take which object? Second is the third object now. So 1.5. That means third object I need to take. The total weight of third object is 10, but I want only 5. Why? Because total weight is 20. Now I placed 15. Now only 5 is left out of 10. So I have to take the 5 by 10 fractional part out of 10. I'm writing here 5 by 10 out of 10. So profit is also 15 into 5 by 10. Now the bag is full, you can see here. So 0 of the third object, that means totally 20 here. So here 0 of the, that's third means this is the first object in our example. So total profit is, you can take it as 5 by 10 means 1 by 2. So 31.5. 31.5 is the profit. Now we can conclude that 31.5 is an optimal solution of this problem. Why? Because we followed this procedure. According to that, you are getting the answer as 31.5. This is our optimal solution. So you cannot get more than 31.5 even if you take any order. And what about x1, x2, x3 values? The first object here we have not taken. Second object, what is the second object? That is I have taken first, no? 1. Third object, that is 1 by 2. So like this, that is 5 by 10 I have written as 1 by 2. Like this you can take. This is our optimal solution here. So this is of the problem how you can find. Especially you need to remember this one, that is profit by weight ratio. So this is a procedure I have given here, and you can pass it and you can write if you want. Now if you consider the algorithm part, so for the same method, that is for the same application knapsack, how the algorithm will work is, you can see here algorithm greedy knapsack m comma n, m is 20, in our example n is 3. So p of 1 to n means profits we have taken, w of 1 to n weights we have taken. So m equals 20, n equals to 3. So p of 1 to n is the profits, w of 1 to n weights we have taken in the previous example, and such that p of I and w of I is greater than or equal. See, in our example, what will be our input has to be taken is in the order of profits by weight ratio. If you take in the previous example, p1 is 25, but in our example, in this ratio you need to consider. That means previous p2 will become now p1, previous p3 will become now p2, previous p1 will become now p3. So same thing for w also. Like this order you need to consider here. So if I consider that order, here you can see for I equals to 1 to n, that is x of I is 0. Here I am writing x of 1 is 0.0, x of 2 0.0, x of 3 0.0. Like this we need to consider. And now u equals to m. So u equals to m, that is capacity, that is 20. So w of for I equals to 1 I will take here. So w of 1, what is w of 1? Weight of the first object I need to consider in our example. Anyway, I'll write first here instead of avoiding confusion. So p1, p2, p3, w1, w2, w3. So like this we need to write. So now w of 1, that is 15. 15 is greater than 20? No. So it didn't go for break, and it comes to here x of I is equal to 1 point. That means x of 1 equals to, instead of 0.0, 1.0. No. Coming to the second, I equals to 2. So w of 2 is 10. 10 is greater than, what is, see, previously we have not updated u value. U value is 20 minus 15, that is 5 only. So now 10 is greater than 5, yes. Now you can go for, if this is true, then break. So break in the sense it comes out of the loop, and you can see here I value is 2, n value is 3. So 2 is less than 3, yes. So x of 2 is equals to, see, x of 2 equals to u means 5 by w of I, 10. So 5 by 10 means, which is 0.5. So like this you need to write, and it goes. Now you can see the values, x1, x2, x3 values, that is x1, x2, x3, 1, that is 0.5. Of course I'll write here as 1 by 2 and 0. So in the previous example we have taken, there also we received the same thing here. So 1, 1 by 2, 0. Of course this is a second object. Now we have taken first object, no? Like this, 1, 1 by 2, 0. So this is a procedure of finding or getting the knapsack problem solution by using greedy method. So here we received the optimal solution, that is order is 1 taking the object 1 as entire, object 2 as half, object 3 null. So that's what. Thank you.